I've gotten. And everything in the kit should be enough to make a rocket that looks either like this, or like this, or like this. And let's just see what's in the kit, and we'll talk a little bit about what you need at home as well. First of all, you're going to see these two yellow pieces. These are streamers. These are to attach to your rocket on the recovery system so that it will come back down to Earth gently. You can use both of them. You really only need one though. If you want to use both, you can, but you get an extra one there just in case you make some mistake. Here's a dowel. The dowel is to make the body of your rocket. You're going to wrap some paper around this and then some packing tape to make it nice and strong to make the body of your rocket. This is not going to be part of your rocket. It's just to make the rocket. When you're done with this, please return it to the school so that we can use it for future generations. That would be great. You're also going to get a piece of foam core board. This is to make the fins. The fins for the rocket right here are made out of foam core board. You can also use other materials if you want. You can use balsa wood or just plain cardboard if you want. You can see this rocket has those fins made out of this material. It's really nice material, makes great fins. And there should be plenty of there. Just make sure you don't cut it out of the middle. Just cut it out of the edges because there's straight edges around the edges already. You're going to have two corks. These are to make the nose cone with. If you see the nose cone on this one, hasn't been painted. Here's the nose cone on this one. I'd say that's a C job, not an A job. And then here's a nice one right here. It's really nicely formed. It looks like a bullet, which is what the nose cone should look like. Think about why a bullet is shaped the way it is, so that it cuts through the air. Same thing with a rocket nose cone. All right, and you have two of them because if you mess up on one, then you get a spare. Or if you want to make a rocket with a that can hold an altimeter in it, you need an extra compartment, an extra piece of your rocket like this. And so you're going to need one cork for here and then one cork to hold the two pieces together. So that's why you have two if you want to do that. If you are going to put an altimeter in your rocket to actually measure how high it goes. We're going to calculate how high. You can use physics to calculate how high it should go, but then you never know until you actually measure it. So two corks, a piece of sandpaper to sand with. If you have more different grits at home, you can use that. This is just one grit, but it works fine. You'll see in the video what that's used for. And then two little pieces of straw. These are for a launch lug. You can see it on this rocket right here, or on this rocket right here. There's one right there. If you have a longer rocket, you might put one top and bottom, but you really only need one. But there are two in there again, just in case you make a mistake with that, you get a little extra. There's a piece of paper here with some circles and lines on it. That is to align up the fins. You'll see how that works in the video. And then you have a little package here that has a piece of bungee cord, very stretchy, and that's to be used as a shock cord. You saw it for a second in here. It connects the two pieces of the rocket together. And on this one, it's here. Okay, so it connects the two pieces of the rocket together, and you can see there's the recovery, the streamer right there. Okay, and the last but not least is some gummed packing tape. And this tape is very strong, and it's going to make the body of our rocket. And you should have about 6 feet of that. That's a lot. So if you make a mistake, you've got enough to try it 2 times. Now, if you've tried 2 times and you messed up and you still don't have a good rocket, we're going to leave some extra pre-made body tubes in the office that you can pick up, just so that you don't get too frustrated in that, so you actually can make a rocket. Because this can be frustrating if you make too many mistakes. So those are the pieces that we provide for you. Things that you're going to need from your home is some computer paper, just like 2 pieces maybe of computer paper to be used in various parts. You'll see how that works in the video. You'll need a sponge to put some water on this to activate it, a damp sponge. You'll need some scissors to cut things like this. And you'll need a knife probably to cut the tube here. Okay, some kind of a knife. If you have an X-Acto knife or a utility knife, you'll see me using a utility knife in the video. Those work pretty good. But if you don't have one of those, just a regular kitchen knife will work fine. You can use a kitchen knife to cut the body tube. You're also going to need some Elmer's glue. Elmer's glue is very strong. It's much stronger than hot glue would be. It's lighter as well, so it's going to make your rocket light. The lighter your rocket is, the less the higher it's going to go, right? Because less mass equals more force, right? Equals more acceleration, right? Because mass and acceleration are inversely proportional. You're also going to need a pen or a pencil to mark something. You're going to need some paint if you want to paint it. You can see these are painted pretty cool in different ways. And then you might need some tape. You're going to need some tape, either masking tape. I would prefer masking tape, which you'll see in the video, or you can, in a pinch, you can use Scotch tape. It works okay as well. All right. And those are the materials. And again, you should get all of this in your kit. And like I said, the things that you're going to hopefully will get this back, because these are expensive and they cost the school something. But the rest of it, and if you don't use one of the corks, we'd appreciate getting that back too. But again, that's all for you to use to make your rocket. Hello, this video is going to tell you how to make your own rocket. So if you're making a rocket from scratch, we're going to do everything from scratch. So let's take a look and see what we've got to work with. Now, this is what we want to end up with. Is a rocket that has the following components. It's going to have a tube, a body, and the first thing I'll show you is how to make the body tube. It's going to have fins that are going to stabilize the rocket so that it flies straight. It's going to have a little piece of straw here that acts as a launch lug that will keep it straight for the first 3 feet of its flight. And has a nose cone here made out of cork. We'll show you how to make that. And then it has a piece of string that ties the body tube to the cork, and with a little piece of streamer in between. This is the recovery system. This is for when the rocket comes back down so that it will fly, that it will tumble down safely and won't kill people on the ground. Now this one has an engine that's spent in the back of it. These are commercially produced engines that we buy. Here's one right here, A83. We'll talk about what those numbers mean later. And these are, here's a bigger one, an E. The impulse that it imparts is by the letter, and goes from A. This one's E. Here's one that's a G. The higher, the later the letter in the alphabet, the more impulse it has. Obviously, this has much more oomph to it. So we'll talk about again what the letters mean and what that means as far as your rocket. Obviously, for an engine such as this or this, the body tube we're going to build today will not work. If you're interested in building a rocket with a bigger than an A, B, or C engine, which is this size, all A, Bs, and Cs are this size. If you want a bigger rocket, you're going to have to make a different body tube, or what people have done in the past is just use some kind of tube that you have around the house, like a wrapping paper tube or something like that. Those work pretty good for a larger rocket. And if we have, and later on, we'll show you some examples of those. Now, if you want to put an accelerometer into your rocket, you're going to have an extra part, which would be this part right here. This rocket is made, and the nose cone would go in here. I don't have the nose cone with me for this one. And this top component here is where the accelerometer would go. That would tell, or not the accelerometer, the altimeter, excuse me. So the altimeter would tell you how high the rocket went. And then on this side, it looks a lot like this one. It's got the same kind of a recovery system. And here's the streamer that comes out. So you'll notice it just has this extra piece that you have to make with a piece of with a cork that holds the two pieces together. So you're going to have to make an extra one of those if you want to put an altimeter in your rocket to measure how high it actually goes. So we're going to explain exactly how to make each one of those pieces from scratch, of course, except for these, which you'll have to purchase, or you may be provided with one of these, for your class. If you're provided for one of these for your class, that's great. Then you don't have to purchase it. I think for the higher ones, the higher powered engines, you're probably going to have to buy one of those if you want to do one of those. But those are very rewarding, require a lot of extra work, but it's worth it when you see it fly. It's amazing sometimes. Okay, so here's what we're going to do. First, we need to make a body tube that looks like this or like this. And in order to make the body tube, we are going to take some tape. Now this is packing tape, and it is non-reinforced packing tape. They make most of the stuff that you buy is reinforced. I would say that you want the non-reinforced stuff, because the reinforced stuff has fiberglass ribs in it, and those make ridges on your rocket, which will slow it down and won't help it fly any better. Now the first thing I'm going to do is I'm going to cut the tape at a 45-degree angle like that. And then I'm going to measure out a piece of tape that's just about 1.5 times as long as I want my rocket to be. So if I want the rocket to be that time, I'm going to go about 1.5 or 2 times as long. And then I'm just going to cut off a piece. I've got plenty of that. And then I can put the roll aside, and this is going to be a lot easier to work with. Now, one side of this is gum, the other side isn't. We're going to wrap it around like this. And to make a tube shape, I have a dowel that's the correct size. This is the correct size for making a rocket. So if I just got this wet and wrapped it around the bar, it would stick to the bar, and then I'd have a piece of paper on a bar. I wouldn't have a rocket. So I have to cover the bar with a piece of paper, and then I'm going to glue this to the piece of paper, and then I will have a hollow rocket tube. So let's see how we do that. First, we take the paper. Take a regular 8.5 by 11 sheet of paper and cut it in half, hot dog style. All right, so that each piece looks like a hot dog, not a square. Okay. And I'm going to wrap it around the tube. And again, these tubes are just the bars that we have in class. If you're in class, hopefully you'll have one of these. It's the exact right size to make a rocket out of. If you're at home, you can purchase a dowel, or maybe you might have been provided one by the school if you're lucky, that you can wrap around, your body tube around. I'm going to get a bunch of small pieces of tape here. Now these pieces of tape, you don't want them overly big, because they add mass to your rocket, which will make it so it doesn't fly as high. But they will also make it less even than it should be. It wants to be nice and smooth and even. And the more bumps we have in the rocket, the less even it is. So I'm going to put a piece of tape on here. And I made this paper pretty tight on there. By rolling it like this, you should be able to tighten it up on the tube. Make it tight. It should still be able to slide like this, but it should be fairly tight on there. You don't want it so tight so it won't slide like that. But if there's little bumps, if you push it and it wiggles a little bit, that's not so good. Okay, you want it as tight as you can get it while still being able to slide it on the bar. All right, and you can just roll it again while you hold it, and that tightens it up a little bit. All right, there we go. I've got one more piece I'm going to put on here. All right, so there's that. And now you can make one, like this one was made with just one piece of paper. You can see for this one I need 2 pieces of paper. So I'm going to put 2 pieces of paper on here just like this. Put the other one so it overlaps about 1/4 inch. It doesn't have to overlap a lot, but it does have to overlap a little bit Otherwise, there'll be, if it doesn't overlap, the sticky paper will stick to the bar, and then again, you won't have a rocket. You'll have some tape that's stuck to a bar. So I'm tightening it up. I'm going to take a piece of tape. I have one more. I'm going to put the piece of tape so it holds the two. You need at least one piece of tape that goes from one paper to the other so it holds the two together. And then again, I'm going to go down here and put more little pieces of tape on here. And these are not crucial because these are going to get covered up. So they shouldn't introduce too much unevenness. Again, the more unevenness you have in your rocket, the more air resistance it will have, which means it won't go as high. So you don't want that. You want it to be as smooth as possible. And plus, aesthetically, it's a lot more pleasing if it's even and not all bumpy. Okay, so there we go. And you can see I can still move the paper on the rod, right? It still moves on the rod. So now comes the next part, which is to stick the paper onto the rod. And this is probably the hardest part of the whole project. Oh, I'm going to stand up for this part. And here's the idea is you want to put it so that this 45-degree cut goes straight perpendicular to the rod. And then you're going to, with the glued side up here, and you're going to roll it so that this cut end forms the end of your rocket. It should roll right up against the end of there. So I need to have a wet sponge. Okay, so that's one of the things you need is a wet sponge. And I'm not going to get the whole thing wet because that would make it too hard to work with. I'm just going to get the first few inches of it wet, and then I'm going to put it on the rocket. Now, if you have trouble doing this, which many people do, don't get discouraged. This is the point at which some people will get very discouraged with this project because it can be very difficult. Okay, and I'm wrapping it up. I'm pressing down on the bar so that it flattens the paper out. And now, once I get it started right, I'll just have to put some more water on it and keep on rolling and trying to keep it flat. If I don't keep it flat, it's going to be, like I said, there's going to be bumps in my rocket. I don't want bumps. I want it to be flat. This is not coming out really bad. It's coming out pretty good. And again, continue to do that. Get lots of water on it. You can see that there's plenty of water on the paper. It's not dry at all. It has to be completely, it shouldn't be soaked all the way through. Like this got a little too wet here. You can see where there's a little too much water on it. That's okay. That won't hurt anything. If it's too dry, it won't activate the gum, and you want the gum to activate so it sticks all together. Okay, now I'm getting down to the end here, and you can see if I keep on going, this part's going to stick to the bar, so I'm going to cut off that part that would stick to the bar. And again, when you get ready to make this, you should replay this video a few times just so you see exactly what happens. And so and again, I'm cutting it and trying to cut it at another 45-degree angle so that when it gets down to the end here, it forms the end of my rocket. And I didn't do that exactly perfectly, but that's pretty darn good. If you can get one that looks pretty good like that, you've done a really good job. And so there we have this. Now, you could take this off the rod right now, but if you do, it's probably going to curve because as this dries, it will all tend to twist. So I'm going to leave it right on this rod until it's almost dry. Just every once in a while, I'll come over and just wiggle it a little bit to make sure it's not sticking to the rod. And then after about a half an hour, I can take that off the rod, and that will be a good rocket. That will be a good tube for myself. Okay, so that part is done. While we're waiting for that to dry, we'll talk a little bit about some of the other parts of the rocket, and specifically I want to talk about these engines. So these engines are really highly engineered And they do three things. They first, we're going to stick a wire into this end of it and run electricity through it, and that will light the fuel that's inside here. And then hot gases will come out this end, which would be this end of the rocket, which would make the rocket go up. So it would be like this, and would go up like this. Okay. So it would be conservation of momentum, right? Gases go this way, rocket goes that way, right? Or action reaction, right? Rocket pushes the gases this way, the gases push the rocket that way. Okay? And the rocket goes up. That's the first phase, is the fuel phase, the burn phase. Inside the rocket, that's a separate chamber. It's black powder in there. Burns really, really hot, gives a lot of energy, and makes the rocket go up. The second phase is delay charge. And once all the fuel has been burnt, it lights a second phase, and that is just going to send some white smoke out the back, so you can trace the rocket and see where it's going. Because once it gets pretty high, it's harder to see. So then that's just a delay charge. This one, this second number here, this one says A8-3, and the 3 tells you the delay charge. That tells you that they'll send 3 seconds of smoke before it starts the third phase. So again, first phase, burn. Second phase, delay. Third phase, what it will do is after those 3 seconds of smoke producing, after it's burnt, it's going to burn for a second or so, and then it's going to have three seconds of smoke, and then after that, it will send the third phase, which is a charge, an explosive charge that goes up this way. So that's going to send an explosive charge inside your rocket up through the body tube, and that's going to blow this part of it off the engine, off the rocket, and then at that point, that's going to make it so that it can safely return. So that's the part that ejects this part, which is the recovery system, out of the rocket, so that the rocket can come back down safely. So then again, there's 3 phases, highly engineered engine. It looks like a cardboard tube, but it's really very highly engineered inside there. Even rockets like this, same way. You can see this one has a lot more fuel in it, and it goes right to the end. This one is an A engine. It's not anywhere near hot. It's not even half full. A B engine would be about 2/3 full, and a C engine would be full of propellant. This one is full, and this is an E engine. It has the same 3 phases, though: a burn phase, smoke phase, and then an ejection charge that goes this way, the opposite way, right? And you can see it's held in place with a clay cap there, but that cap is very thin, and when the blast charge goes, it will blast that right up into your rocket. And again, that's meant so that it makes the recovery system come out, so that your rocket comes down safely and doesn't come down like a dart. Now, if you don't put the rocket together right, don't have a recovery system in it, obviously a rocket can be very dangerous when it comes down without a recovery system. So we're going to make sure that we inspect your rocket so that before you fly it, it's safe to fly and it won't hurt anybody. Or damage property, that wouldn't be good either. We've had some rockets that, not because they weren't inspected, but just because they failed during flight, that damaged property before. So we're trying not to do that as much as possible. So those are the parts. Now, we just talked about how to make the body tube out of paper and some tape. The fins can be made out of many different materials. These fins are made out of foam core board, so your presentation board for a poster or presentation or whatever. You can also make fins out of just plain old cardboard if you want, or you can make them out of wood, out of balsa wood. Balsa wood makes great fins. A little more expensive to get the balsa wood, but it's in some ways it's easier to work with too, because you don't have to deal with the foam core board. Is a little difficult because it's got paper on the outside and then foam core inside of it. So sanding it is a little problematic. All right, so those are the materials that again, this is just a little piece of straw that's easy enough to find. This is a little piece of bungee cord here, which should be provided in the kit that you get. take-home kit to make a rocket at home, or it's in class if you don't. And then this is just a piece of plastic that can be cut into strips, and then it's tied around that part. And again, there are corks. We have plenty of corks. Again, there should be corks in your kit, or in the classroom if you make it in school. And those are the basic parts that you're going to need to make a rocket. In addition to that, obviously materials to decorate with. This is done with paint. There's some glitter dots on here, which is kind of cool. This one has glitter on the fins. So I would encourage you to decorate your rocket after you get it all built. Make it look really nice. So there's the basics. And the next part of this video, once our body tube is dry, we'll talk about trimming the body tube, and then making the fins, and then attaching the fins to the body tube. So. Okay, let's take a look at how our body tube came out, and we'll take it from there. Let's see. So yesterday I made this, and it's dried now, and it's really tight on there, but it does slide off. So we have our body tube here. Before we slide it off though, we're going to trim it to length. And to do that, I'm going to need a knife, some kind of knife that you might have. And I'm just going to cut right here. And I'm going to turn the bar as I cut, kind of sawing it. And I leave it on the bar so that, because if you take it off the bar, it's going to crush the tube, and I don't want to crush the tube. I want it to retain its round shape. So I just kind of sawing through the paper, because you have to go through the paper and through the tape. So it takes a little bit of sawing. And you get it all the way around, you should be able to just separate this out once you get it all done. Let's see what we got. And that wasn't. And again, you might not do this so great. I didn't do it so great. I think last time when I made the tube, I made it look pretty easy. I don't think you'll find that's that easy. There should be some extra tape in your kit just in case when you made your tube you made some mistakes and want to start over again. And you can see I'm making a mess out of this, but I think it's going to turn out okay anyway. So let's see what we got here. Let's see if we can pull the end of this off. And like usual, if you're using a knife, just be careful you don't cut yourself, because this knife would go through your fingers a lot easier than it would go through this tape, this paper. So I'm trimming the end because the end part is a little uneven. You know, it's got some taper there, and the tape might not be going all the way through. There we go. I think that's got it. Here it comes. There we go. I got one piece right there. There we go. Now I have a nice even end on that side. I'm going to do the same thing to the other side. And I can see that I'm going straight. This one is going to turn out a little better. One that comes out the best I'll probably use for the behind part of the rear end part of the rocket, because I want that to be nice and smooth for when I make my fins. Okay. So there we go. So there's our body tube right there, all done. Now, if I was going to make this with an altimeter, I would cut off about this much. I put it back on there and cut it right about there. And then I have this piece for the altimeter compartment, and then this would be the main body of my rocket. I'm just going to make it like this for the purposes of this video. So put the bar, we're all done with the bar now. I can put that away. And I want to make some fins, and I'm going to make the fins out of, this is a piece of foam core board. They just happen to have sitting around. There should be some in your kit. Now, to figure out what I want for a shape, you can copy a shape here, like I copy this shape, or I could design my own, or I could look in a book and see for some interesting fin shapes. Here's a catalog from Estes Rockets, who makes the engines, and there are some pictures of rockets, and you can look at those and get some ideas for what a fin might look like. See, there's some that are kind of swept back. There's some more that are more, there's some that are like rectangles. I wouldn't recommend rectangles. In general, you want them to sweep back a little bit like this. Do not do these here. But you want them to sweep back a little bit more to make them more aerodynamic. Okay, and they will give you less air resistance, which means the rocket will go a little higher. So anything that looks, notice how they look like they're swept back. They look really sleek, and that's what you want. These like here are kind of neat. So I'm going to just kind of design my own. I'm going to take a piece of paper and I'm going to draw a design on it that I think is going to look good with my rocket. So I'm going to hold my rocket right here, and then I'm just going to draw something that looks like it might be the right size for my rocket. I don't want it too big for the rocket, but I don't want it to be too small either. So I'm thinking something like that. That looks kind of nice right there. So I've got that like that, and then I'm just going to cut that out and use that as a template. And of course, I'm going to try to cut it straighter than what I drew. There we go. So there's my fin. So I'm going to make 3 fins that look like this. You could have 3, 4, or 5 fins if you want. And you'll look at in your kit, there should be a template for how to place the fins around the body too. We'll look at that next time on the next part of the video. But for now, I'm just going to cut these fins out and kind of prepare them by placing this onto here, and that's going to give me, I'm going to see where to draw or where to cut my fins by tracing out my template there that I cut out of a piece of paper. Okay. Once I get one of them made, I'm going to be able to use that other one as a template, the one that I made. So here we go. And be careful, like I said, as always, with a knife. These knives are very sharp. If you're at home, some kind of an X-Acto knife would be better. A very sharp kitchen knife would work okay for this. I wouldn't recommend you using scissors because it tends to crush the foam core board and take, and it bends the fins if you use scissors to cut these. I mean, I've had some people who have been successful with it, but many people who are not happy with the way their fins come out when they cut them with scissors. So again, I recommend a very sharp knife. Here I have a utility knife, and I've cut that fin out like that. And then I'm going to cut 2 more. I'm also going to, this is the part that goes onto the rocket right here. That's the way it's supposed to look. It looks pretty good. So I'm going to sand that flat, and I'm going to round these a little bit with some sandpaper, and then make 2 more of these, and then we'll have the fins as well as the rocket already. And that's it for this part of the video. All right, in this segment, we're going to take a look at how to put the fins on and how to align them using some simple tools that we have here. You're going to need a fin alignment guide, which should be in your kit. You're going to need a body tube that we made before. You're going to need fins that we made before, and something to mark with, as well as a piece of sandpaper, which should be in your kit, and some Elmer's glue and a hot glue gun if you have it. If you don't, you can use Elmer's glue all, and just it'll be a little bit more difficult, but it should work. Okay, so the first thing we have is if you see these fins, they're a little bit uneven, and we want to make them even. So I'm going to hold them together and sand them on the sandpaper until they're all the same size and shape. And it should not take you too long. And this is going to even out any of the irregularities that happened when you made the fins, because we are humans, we're not machines, so we can't make things perfectly. So this will help eliminate all of those imperfections. This edge right here is the edge that's going to go on a rocket. I want to make sure that that one in particular is very smooth, because that needs to be smooth in order to attach to the rocket. And then the other ones, obviously I would like to have all these fins the same size. Some of them are going to be better than others. And if you hold on to them, they should eventually end up to be all the same shape and size. Keep on getting closer. You make a mess when you do this. But that's science, right? Science is a little messy sometimes. All right, there we go. That's pretty good right now. You can see that they all look pretty smooth and even. All the sides are the same pretty much. I got a little imperfection here, but that's going to be okay. Now once we have it like this, you might want to just sand the edges a little bit and make sure you get rid of all the imperfections. Not crucial, but it helps a little bit. Here's the edge that's going to attach to the fin right here. And like I said, I want to make sure that that one's in really good shape. These other ones, you can actually feather these if you want, make them pointed if you a little bit want. I'm not going to do that right now, but there's lots of resources online if you want to make those nice and aerodynamic, to sand them down. I'm just going to leave them the way they are right for now. And again, when you design these fins, you can use your imagination. Come up with a fin that's different. Almost any size or shape fin will work, as long as it's aerodynamic and it's not unbalanced. All these fins must be balanced. They have to be the same size and shape. Otherwise, the rocket will spin or it will go sideways, both of which are things you don't want. All right, so that's pretty good. I got that pretty well done. And now we're going to take a look at how to attach the fins to the rocket. First, I have to mark my body tube so that I know where each fin goes. And in order to do that, I have 3. So I'm going to use these 3 lines. They're all 120 degrees apart. 1, 2, 3. If I had 4 fins, I'd use the ones in the cross. But I have the other 3. So I'm going to put the body tube on here and try to make it the same size so it's centered on the circle. And these circles are handy in helping you to do that. And then I'm going to make a little mark at the bottom, on the bottom of my tube, where each line lines up. And again, you can see that this moves around a little bit while you do it. It's not going to be perfect here, but well, they say perfect is the enemy of good. And that's pretty good. I got it pretty good. All right. So there we go. So then we're all done with this. But now I have little lines on the bottom here. 3 little lines. I need to make the line, extend the line so I can line this up along it and make it straight. So that's what this little book is here for. Now I'm going to put the body tube on the book and line it so the edge of the book is right where the line is, and then just extend the line up. Like that. There we go. There's another one. You can tell I'm a teacher. I have a red pen here. Teachers love red pens, don't they? All right. So there we go. I have the lines marked. And now I'm going to put some glue on one of these. And I'll show you how to do one, and then we'll come back when we get all 3 done. Okay. I'm not going to take you through all 3. This is going to be a little bit tedious. But I will do one and show you how to do that. So this is where it helps to have that hot glue gun. If you don't have a hot glue gun, you're going to have to just kind of hold it in place until it's dry enough, which could take 10 minutes. Okay, but this way I found works pretty good. So I'm going to line the fin up so that the bottom here is even with the bottom of my rocket. All right. And it's lined up like there. Now that won't stay, right? But if I take a glue gun, see if my hot glue gun is ready. Yeah, my hot glue gun is ready. If I take my hot glue gun and just put a dab of hot glue on the top, so right here, I'm going to put a dab of hot glue right there, and then another dab of hot glue back here. And that should hold the fin in place so I can do all 3 at once. All right, and once I get all 3 on there, I'm going to store it someplace like this so that the fins dry and they don't pull off the rocket. And again, if you put a little extra hot glue on there, later on I'm going to pick that hot glue off. I got quite a bit on there. It's a big glob, but I'm going to pick it off later so it's more smooth. So that's not going to stay. But the Elmer's glue is what we want to use to attach the fins, because the Elmer's glue is for one thing, it's a lot stronger than the hot glue. And it won't melt because inside here it's going to get really hot. The engine will make this really hot, and if you use the hot glue, it will melt and the fins will fall off. So it's the Elmer's glue that stays. The hot glue is there just to hold it in place until it dries. Okay, and by now, and if you just have to wait like a minute for the hot glue to cool down, and that should hold the fin in place. And there you go. And once I get all 3 of those done, we'll take a look at the fins and see what needs to be done next. Okay, we left off last time with one fin. I showed you how one fin went on, and now I have all 3 fins attached here. And I've also taken the hot glue off. So I picked it off very carefully, pick it off so that all that's holding the fins on now is the Elmer's glue. And you see it was bumped up and it's pretty smooth there now. What I'm going to do now is to just put a little extra Elmer's glue into the edges so that it strengthens the bond there. Okay. And some people will take Elmer's glue and paint the whole tube with Elmer's glue. You can do that if you want. That's going to add some strength, and it's makes it a little bit smoother. So when you paint it, it looks a little better. But I don't usually do that. I usually just put the glue into these little seams just to make those a little bit stronger. So I'll put the glue in here like this. Just put a little glue in there. And then just take a paintbrush if you've got one, or you can just run your finger along it and smooth it out. All right. And then once you're done with that, you can put this aside for a moment. and we're going to build something else. Okay, so there we go. Oops, I missed this side right here. Here we go. Just make it nice and smooth. And again, that'll dry up and you won't be able to see any of the unevenness there because it's really strong and it dries really smooth. That's the beauty of the Elmer's glue as opposed to hot glue, which stays big and clumpy. All right, so there we go. So that's ready. Now today we're going to, or this time we're going to take a look at how to make your recovery system. This is going to be my nose cone. It won't fit in there. Oh, it goes in there just right on that end. So I need to shape the other end so it looks more like a bullet. So it will be aerodynamic as it goes through the air. And I'm going to do that using some sandpaper. This is going to make a mess. But and it's going to take some patience. But after a while, you will get to the point where you have a nicely shaped nose cone. And you notice it's a little blunt now, but it's got to be a lot more blunt than that. So I'm going to continue to work on it. Get this over here. And I'm sanding it and continue to just keep on turning it as I sand it. Sometimes you would take the piece of sandpaper like this and twist it and just twist it in there. Sometimes that works good too. So you can do it this way too. Hold on to the sandpaper and just twist the cork. And that's going to get it more even all the way around. So, and if you use a combination of these things, it'll come out better. And we're getting there. Just keep on trying. This may take you a little bit more time than it's taking me, just because I know exactly what I want to do. It does take some muscle power though. It's a good workout. You can see how it's getting better now. It's getting closer to what we want. I'm going to spin it a little bit, even it out. Oh, we're getting there. Every once in a while I take a look and see if it looks like the right shape. It looks like it's coming out pretty good. So I'll just, I got one spot here that looks like it's a little high. I'm going to sand that down a little bit more before I go too much further. That's looking pretty good right there. I'm just going to spin it a little bit more, see if I can make sure it's even all the way around. And there we go. Look at that. That looks pretty darn good. So there we go. And I think that's about ready. That looks pretty good. Looks like a rocket. And again, if I had more time, I might spend a little bit more time on this. Looks like there's a little bump over here maybe. But I'm going to call it good for now. All right. So, and again, you can spend as much time on sanding that as you want until you get it as perfect as you want it to be. Don't forget that perfect is the enemy of good, right? So don't make it, don't feel like it has to be perfect, but that's pretty good right there. Now we need to be able to connect this. This is your bungee cord, shock cord, so that when this comes flying out, it doesn't rip the paper. It's got some slack in it, but I need to connect this to the cork, and then I need to connect this inside my body tube. Okay, and that's going to be very tricky to do. So first part, to connect this to the shock cord, I'm going to try to drill a little hole in the end here. Now be careful. First of all, scissors are dangerous, but also if you push the scissors in here too hard, you're going to split the cork. So I just put it in there a little bit and then spin the cork, and you should work a little bit of the cork should come out at a time. You can see the little pieces of cork coming out here. Just a little bit at a time. Don't get carried away, and don't try to do it all at once. Just spin it and twist it a little bit with the scissors. You can do this with a knife. Some people use a drill to do it. If you have access to a shop, you can use a drill to do this. This works just as well, though, as a drill would. And just keep on going. I want to have at least a ½ inch in there. I'm pretty close to that right now. So I'm just going to go a little bit more and get some more of that cork out of there. Let's see how far in I am. I got about 3/4 of an inch in there. I think I'm just about done. So just get a little bit more of the cork out of there. And let's test it to see how much of this will go in there. So I see I only got about ½ inch in there. That's pretty close. I'm just going to do it a little bit more. There we go. Okay, so that's good. Now to attach it, it's pretty easy. What you have to do is take a hot glue gun. So here's my hot glue gun. And stick the stretchy cord in there. And then stick the hot glue right in there and just pump the hole full of hot glue. And there we go. Now that's going to take a while for it to dry, to cool down and solidify. So I'm just going to put this aside for a second before I do anything else. Right after a few minutes, if you pull on that right now, it's just going to come right out. So let it dry for a few minutes like that. And we'll talk about what needs to be done for the next part. So for the next part, I need to glue this inside the tube. Now, if I just used a little glue and try to put it in there, it would rip right out because it's hard to attach this to the side of the inside of the rocket. So we're going to glue this to a piece of paper and then glue the piece of paper down inside there. So I need to get a piece of paper. And the piece of paper doesn't need to be really big. It's going to be a small piece of paper because if it's big, it will take up too much room inside there. So again, just take a piece of scrap paper. And I'm going to cut a little piece of paper out of here. It's about that big. Okay, that's all you need. All right, about as wide as the tube, and then about 3 times as long as it is wide. And we're going to smother this with Elmer's glue so it gets nice and gluey. All right, don't be afraid of the glue here. We're going to use a lot of glue, which means it's going to take a while to dry. So here's another step we're going to do, and then we're going to have to account for some drying time before we do any more of our work on our rocket. So there's a couple spots, at least 2, maybe 3 spots where you have some drying time. And then of course, if you're going to paint it, there's more drying time there. So when you think about doing this project, it's going to take you a while. All right, so I'm going to make a loop like this, just like a little half a loop. So it's fold it over once and stick it right in the glue. And then I'm going to just fold this piece of paper over it like that. Okay, there we go. Now I got a little package that's all glue. And if this, and I'm going to glue this to the inside, and that's going to be a good bond. And if this, if this wants to pull out, it's going to have to pull out all the paper inside the rocket, which it probably won't. So I put some more glue on this part here. I'm running out of glue here. All right. Come on, glue. You can do it. And notice I'm using Elmer's glue for this because it's going to be much stronger. And I need this to be strong. The hot glue would be easier to work with, but it's not as strong. So there we go. I got enough on there. Now I'm just going to spread it around nice. All right, there we go. And now I'm going to reach in there. Now this has to go in here far enough so that when this is all the way in, this has to be out of the way. There has to be some room. So I'm going to say it needs to go down in there about that much, okay? So I'm just going to hold on to the cord and push it down in there that far, okay? And then I'm going to use the back end of my paintbrush to push it against the side of the rocket, okay? And flatten it out against the side of the rocket because it needs to be as flat as possible against the side of the rocket. All right. When you get done, it should, I mean, it's going to stick up a little bit from the side of the rocket, but it should mostly be against the side of the rocket pretty good. And I don't know if you can see it in there or not, but you can see that you should be able to see right through the rocket there. And you can see the little bundle of paper and the shock cord. So there we have it. So there's most of our recovery system done. The only thing we have left to do is to put on the streamer, and we also have to put on a launch lug, and then we'll be ready to paint our rocket. So there we go. On our rocket, and that would be just to finish putting together the streamers and then putting the launch lug on. So you have a couple of these here. If you have a really long rocket, you might want to put two of these, one up top and bottom, but we really only need one for the rocket we're making here. Here are some streamers. You should have these in your kit, and you want those to go in the middle of this. So I'm going to tie the middle of the streamer to the middle of the shock cord. All right, and then I just tie it on, and then so that won't slide. I'm going to tie the shock cord around the streamer as well. So double knot here, and that'll make it so it won't move at all. There we go. All right, and then at this point you can put it all back together if you want. I usually like to take the shock cord and roll it up nice and neat so that it will come out of the rocket easily. So I'm going to roll it up here. It doesn't have to be super neat. I'm going to get it in there, and then just push the rest of it in there as well. Shock cord. We probably got more shock cord here than we need. And again, if you want to make your rocket as light as possible, you might not include as much as I did on this. So I push the shock cord up in here. I'm just getting it ready so that I can paint it. And there we go. It's all in there like that. There we go. And then now we need to put the launch lug on. And I usually try to put it so that it's in between these fins, and I'm looking for a spot right about there. Now, if you just try to glue it on there, this straw is very slippery, so the glue will not stick to it. So we're going to have to rough it up a little bit with some sandpaper. Here's my piece of sandpaper right here. So I'm just going to gently sand it all the way around. I mean, that'll make it so that the paint will stick to it too, because the paint won't stick to it either. Again, these are just things that I learned through many years of making these rockets. You need to rough it up, not just for the glue, but also for the paint if you're going to paint it. And you can tell whether it's rough. Oh, that feels nice and rough. That's good. All right. So now it should accept the glue. For this, I'm going to use the hot glue just because it's a lot easier and it dries faster. And it's not even going to be on the launch. It's not going to be on the launch pad long enough for this glue to melt. So even though it's not as strong as Elmer's would be, You can use Elmer's if you want, but this works fine. The hot glue works fine for this part. Never had a problem with these. All right. And there we go. And there you have it. There's your rocket. The next step would be to paint it, and then you'd be ready for launch. Find its mass, and then you can calculate how high it might go based upon physics equations. But that's the basic rocket right there. You got all the pieces that you need. We'll put the engine in before launch, and also put something called recovery wadding in there so that it won't burn up everything inside. I'm going to attach an igniter, put her on the launch pad, and we'll be ready to launch. So there's your homemade rocket. Everything made with the original. And it looks pretty good, right? Not too bad. Not bad. It's not a bad job. All right. Again, there you go. So you can see I got a couple wrinkles there, but you know, it's no big deal. Unless you're a perfectionist. If you're a perfectionist, those would drive you crazy. But for me, that's fine. And again, there is your rocket all built. And so we're going to get ready to prep for launch. And what needs to happen here is this will happen on the day of the launch. But again, and if you're watching this video just to do a rocket in general, you could do this ahead of time. You don't have to do it on the day of launch. But for our purposes, we're going to be doing it out on the field when we have our field day here at school. And so the first thing we need to do is put some little squares here that look like toilet paper, but it's really, this is called recovery wadding, and it's been infused with fire retardant material, chemicals, so that it won't burn and it will prevent fire from starting. So we're going to push this up inside the back of the rocket and then push it up in there with a pencil so that it gets past where the engine's going to be. Okay, and then I'm going to do that with 3 pieces. So I want 3 pieces of recovery wadding in there. And that'll prevent a fire block between the engine and the recovery system, which is up in here. We have the streamer and the shock cord, which we don't want to catch on fire. We want the exhaust gases to push that stuff out of the rocket but not burn it. So, and this will prevent the burning from happening. So again, I'm just pushing it up in there as far as I can reach with a pencil. And these should all be pushed up against each other, so that'll prevent, like I said, these will be able to still be able to be pushed through the rocket, but they will stop the fire from burning the other stuff. Okay, so there's your recovery wadding. The next thing we need to put in there is going to be our engine. And for our project, the engine is B6-4. I'll talk about that in a minute, what that means. But first, if we slide it in there, we're going to see that it's really loose in there. It has to be so tight that you can't really push it in. You can't really get it out. Otherwise, when it makes the rocket go, if it's not tight, it will go up through your rocket and then come out through the nose cone, which would be funny and hilarious to your school classmates, but it would not make for a good rocket flight. So, and if it's not, if it pulls out easily, it won't. I mean, if it won't go in, but it pulls out easily, then when the ejection charge goes off, instead of making your recovery system come out, the engine itself will pop out the back, which you don't want either. You want the recovery system to come off and the engine to stay in the rocket. So it has to be in there just the right amount of tightness. In order to do that, we're going to wrap it with some masking tape, and then it's going to be a little trial and error here to make it work. So let's get the masking tape. Here's my masking tape. Here we go. And you can put masking tape all over this. I'm just going to put it mostly on the back here. And You want it to make like a wedge, so when you push it in, it gets tighter and tighter the further you push it in. So think about, you want more tape on the rear end. This is the end where the fire comes out that makes the rocket go, the little hole. So that's the back end of the rocket engine. And so put more tape there than you put up top. But I'm just gonna kind of wing it here. I know roughly how much tape it's gonna take, having done this a few times. So, and again, I want to try to get some more tape here on this end. All right, so let's, once you get some tape on there, I'm gonna test it and see how tight it is. This one may be too tight already, which it is. I got too much tape on there. So we're gonna take some tape off. If I can find the end of the tape. There it is. Just unroll some. I'm gonna save that in case I need it. We're gonna take it right off. All right. Let's leave that right there and let's test it again. Oh, see, now I think that's a little too loose. So I'm going to put a little bit more tape right on the end here. And I want to build up this end part here. Because I would like the end of this to be even with the end of my rocket body tube. That's going to make it so that it flies right. So I'm getting really precise here. I'm cutting this tape in two so I can make it a little bit higher right at the end. A little bit thicker right at the end there. And again, if you're doing this at home and you're not part of the school project, you can have the engine ahead of time and you can put your own tape on. You can experiment with it a little bit to make it fit as well as possible. But and again, this is a process we're going to do the day of when we have our field day. So there we go. Ooh, that's still a little too tight. I got too much there. I'll take some of that last piece of tape I put on there, take some of that off. Let's see if this is going to work. Oh, that's about perfect. It should be so tight that you can push it in with your thumb, but you can't push it with the finger because your finger won't be strong enough to push it. So I got almost all in there. I mean, ideally it would be level with the back, but for what we're doing today, that's fine. And so there we go. We're now, the engine is in there so tight it's not going to come out. And it's called a friction fit. Some rockets, if you buy a rocket, a kit, like at Michael's or some hobby shop like that, you would find that they have a little lug here that holds the engine in place. What holds the engine in place here is just the friction from the tape against the side of the body tube, but that's fine. It's going to work just as well. And the next thing we need to do is put in an igniter, which is we're going to run electricity through the igniter, and it's going to light the engine on fire. Okay. And again, if you're at home, you're going to need some kind of an ignition system, a little battery. Like you can just use a 9-volt battery with some long wires that you would attach to the battery that would send electricity through this wire here. You see there's 2 wires here, and if you make current go through there, up on the top here, there's a very flammable substance. There's some black powder, and there's also a very thin wire that heats up when electricity goes through it. So the wire will heat up and it will burn that stuff, and then that will light the engine on fire. So I'm going to put this inside the bottom here. You have to stuff it in there a little bit as far as it will go. And I've tried to make the wires not so they don't come out on the same side here where the straw is, because the launch rod is going to get in the way of the wires if you do that. So I'm going to bend it over this way and just bend it gently. Like I said, this is why I do this on the field. I always do these on the field just so that they don't get bent on the way down or the way to the field. And then push the plug in there, and the plug's going to hold the wires in place so they don't wiggle. If they start wiggling, sometimes they'll bend or break, and then you press the button on the igniter or flip the switch and nothing happens. So there we have it. Now we're ready for launch. We have an igniter, we have the engine in there, we have the recovery wadding, and we're ready to go down and launch. But we need to do one more thing before we do that, if we want to do our calculations, and that is to measure the mass of the rocket. So I'm going to put it on the scale here. First, let's just make sure the scale is 0. There we go. Put everything on 0. Let's see what we've got. There we go. Oh, that's pretty close. All right. These should be about 50 grams, just a little bit less. Should have a mass around. Mine's going to have a mass of 42.7 grams. 42.7 grams. So that's including the engine. And again, you can get a mass of the rocket without itself, and then add the mass of the rocket without the engine, and then just add the mass of the engine to it, because I can find the mass of the engine right now. Mass of the engine is a B64 engine, is 17.2 grams, 17.2 grams. Okay, so 17.2, figure another gram of tape and recovery wadding, and so 17.2. If you said the engine and the recovery wadding and the tape is 20 grams, that would be pretty accurate. So 20 grams, including the recovery wadding and the tape. And so here we have the engine. It's a B64. I want to explain what that B64 means, because you need that to do the calculations. The B tells the impulse. And in this case, we have a B engine, which means the impulse is 5 Newton seconds of impulse. That means that's a measure of how much power, really, how much force times time that this engine is going to exert on the rocket. So force times time would be 5 Newton seconds for a B. For a, it's 2.5 Newton seconds. For a C, it would be 10 Newton seconds. For a D, it would be 20 Newton seconds. So it's a logarithmic scale. It doubles every time, every letter. So you can figure out how much a G would be. If you did it on this scale, you might find out what letter the space shuttle is. That would be an interesting look at, or what letter the SpaceX engines are, because there certainly would have a letter. It might be like a double A or a double, I don't know, or A, Z, something like that. It would be, because it might be beyond Z, but it would definitely, you could categorize it the same way because it's a logarithmic scale. So eventually you would catch up with it. Now, the B means, again, 5 Newton seconds of impulse, which is the force times the time. And that's going to equal to the change in the net force times the time of burn will equal to the change in momentum of the rocket. So you'll use that to calculate the velocity of the rocket after the first stage burn, after the burning. And then you're going to have a rocket in free fall, and you'll calculate the second phase using free fall equations. So that's how you're going to figure out how high it goes. But now the 6, you need the 6 also. The 6 tells you the average thrust or the average force. So B is 5 Newton seconds of impulse. 6 newtons is the average thrust. Now, impulse is going to be average thrust times time. So time is going to be the impulse divided by the force. So the time of burn, in other words, the amount of time that this is going to burn and provide thrust for the engine, for the rocket, is going to be 5 newton seconds divided by 6 newtons, which will be 5/6 of a second. So that's how long this will burn for. It will be 5/6 of a second. And then whatever letters you have there, you can use those letters to figure out the burn time and the average thrust, and also the impulse that the engine has. The 4 is the delay time, so that tells you how long it's going to be before the ejection charge pushes all the recovery system out. So that's be the time of coasting, and hopefully it doesn't take that long. It doesn't take 4 seconds to reach its peak. If it does, then the recovery system is going to come out beforehand, and it's going to stop. It's basically not going to go any higher at that point. So we'll use the 4 number as well. That's a limiting factor in the equations. Okay, so that's what the letters mean. Again, for this project, everybody's going to have a B6-4 engine. So you're going to have the same engine everybody else does. Every rocket will have a different mass, obviously. So it will go a different height. All right, and that's it. And that's mostly what you need to do. After that, it's going to be launching. And again, for the class project, for the school project, we're going to launch together. There'll be a field day out there. And so you will come out and bring your rocket. You can come with your friends if you want, or come alone. It's okay. And we'll be socially distanced out on the field. And then we'll launch everybody's rocket. We'll get them all ready for launch out there. We'll have a table set up where we're going to assemble, put everything, do all the steps I did in this last segment, and launch your rocket, see how high it goes.